I've got a question for you. Imagine you own a home or a plot of land, something like that. How do you know exactly where your house begins and ends? This might seem like a simple question, right? Maybe you might say, oh, check the survey, but what math does the surveyor use to say, yeah, this is your house and this is not? It's actually not that easy of a question, and there's a lot to surveying and civil engineering, but today we're just going to focus on one tiny element of it all. Now, when we normally think of points, we think of an XY coordinate system, right? And, that works really well for games like Minecraft and whatnot, but we have a slight issue with the Earth. And that, of course, is that Earth is round, right? Take a look at those squares we just had a second ago. Now that I've mapped them onto a sphere, you can see that the size and proportions of them have changed completely. So we're going to need a bit of a different method. As an aside, at the small scale, we absolutely can approximate with the simple XY grid, but what if we have to map something larger, like a town or a state boundary? Or what if we have to map something even larger, like your mom? Hey guys, sorry, I'm running out of memory to render that joke, so I don't really have a visual for you guys. Sorry about that. So let's change up our approach a little bit. Instead of using X and Y, we'll use north, south, east, and west. We'll begin with two letters. The first letter indicates our starting axis, either north or south, and the second letter, either east or west, will show us our direction from that axis. And just like that, we've created a bearing. So one thing that I did forget to mention is what exactly is a degree, minute, and second. So let's take a circle and divide it into 1/360th. That is a degree. Then we're going to take that part, divide that into 1/60th. That is a minute. And then we're going to take that tiny section, divide that into 60ths, and now we have a second. And we're zooming in so much that my animation is struggling to render. So all I got is this green rectangle for you. Finally, I'm just going to show you really quickly how to convert from degrees, minutes, and seconds to regular degrees, because that's pretty important. And also, you might be wondering, why do we use such a weird system? Why don't we just use regular degrees? And the answer really is that that's how it's been done for hundreds of years, and we have old historic documents that are measured in that way, and it works, really, so we don't really need to change it too much. Here's an old survey from the 1930s, and if you zoom in a bit, you'll see that's exactly how locations were measured. You'll also notice that they used a scale of 30 changed to an inch. The reasoning for that was back in the day, those guys were freaks. So let's revisit the sphere animation. Right now I'm using circles to represent bearings, and as you can see, they can wrap around the entire sphere if needed. We've essentially created a way to help us define these boundaries, whether they're really small or really large, on the entire sphere. And that's kind of amazing if you think about it. So hopefully now the next time you look at a map or a survey, you'll have a better idea of exactly why certain things are drawn the way they were, or why they came up with certain ideas in those specific ways. If you enjoyed this video, it's kind of cliche to say this, but give it a like, engage with it positively, share it with some friends who you might think enjoy this stuff. I'm trying to just show all of these cool ideas and concepts in a way that hasn't been done before. So it would really help if you could just share it with people, really. That's the main thing. And with that, that's all I got for you. Thank you for watching.